Since the beginning of mankind, he has looked at the stars and pondered their mysteries. These fascinating objects are so far away that we, or even robot spacecraft, can't go and study them directly. The only way we can learn about them is by studying the radiation they emit and send us at the speed of light across huge distances. That radiation consists of visible light that we can see through telescopes, but also invisible radiation, most of which doesn't even penetrate the Earth's atmosphere. The more successful we are at decoding the radiation messages, the more we can expand our knowledge of the universe. As light is made up of different colors, a telescope with a spectrometer can do the same thing with starlight that a prism does with sunlight. Each star has a unique color pattern. These color patterns are chemical signatures, and like fingerprints, they help identify the star. By looking at the detail of the color patterns or spectra, you can determine the temperature, pressure, and chemical elements in the star. Every element has its own distinctive color. As an example, neon gives off its very characteristic red color. In this tube is hydrogen, and it gives off its purple or violet light. These colors are at the opposite ends of the visible spectrum. For centuries, our only source of information of the universe was by observing visible light using bigger and more powerful optical telescopes. However, the information gathered was still limited. Then in the 20th century, it was discovered that radio waves were coming from space, and this changed our knowledge of the universe. The shuttle was used on one of its voyages to operate the Astro 1 observatory. This was one of NASA's first missions to study astrophysics, the science that investigates the size, mass, temperature, and chemistry of celestial objects like stars and galaxies. Studying celestial objects from observatories on the ground is like listening to music with the high and low notes filtered out. This is why it was important to observe from above the atmosphere. Just like ocean waves, light waves have high points or crests and low points or troughs. The distance from crest to crest is the wavelength, and different frequencies result in different wavelengths. Traveling at the speed of light, radiation vibrates in electromagnetic waves. The electromagnetic spectrum classifies these waves by using their wavelengths and frequencies. Although the spectrum is continuous, it has been divided into 7 categories for easier identification. On one end of the electromagnetic spectrum, radio and microwaves are used for cooking, communication links, and for radar. Radio waves are used for communication, usually in the form of radio and television broadcasts. Although infrared rays can't be seen, you can feel them as heat from the sun or a heat lamp. On the higher energy side of the visible spectrum are ultraviolet rays. To most people, ultraviolet rays are the ones that tan or burn their skin. This happens because although most of the sun's energy is invisible light, our sun is hot enough to emit some ultraviolet light. A small fraction of this reaches us on the ground. To astronomers, ultraradiation tells about hot young stars that have just been born, or hot old stars near their deaths. X-ray photons are even more energetic. When an X-ray picture is taken of your body, the bones absorb the rays while the soft tissue like your skin does not. This kind of picture provides your doctor with important information. Gamma rays have the highest energy and the shortest wavelengths of all. Certain radioactive material emits gamma rays. These rays are used in some forms of medical treatments. However, too much exposure will cause severe illness. The Astro 1 observatory was the first observatory that could simultaneously take ultraviolet pictures of objects, study their ultraviolet and X-ray spectra, and determine their brightness and structure. It has allowed scientists to view the universe in its entire energy range and thus opened a great window to the universe. But this is only a beginning to understanding the universe and its symphony of light.